or suffix of nums. What do you mean there? I don't know. You must write an algorithm that runs in on time and without using the division operation. I kind of remember this question from before. We have two hints. So basically, for each item in the input list, you're going to multiply the rest of it and then write to here, to the same position. So it will be an in place. No, okay, it won't be an in place. Yeah, you can also make it in place and return it at the end. It really depends on the preference, if you like to keep it as it is or if you are fine with changing it, basically mutating this value. But that's okay. For this element, you're going to multiply 1, 3, and 4, which is 12, and you write it here, right? For 3, you're going to multiply 1, 2, and 4, which is 8, and for 4, you're going to multiply the rest, which is 6, and you will write it there. So the why without using the division operation, it is due to to prevent this solution, which is multiplying every element of the nums, calculating the total product, and then for each index you're going to divide it by 1, 2, 3, 4, right, and write it down here. So they want to prevent this, so probably they want more. Yes, they wanted to restrict us. The constraints are it can be minimum of length 2, and the values are relatively small, but that's okay. It's probably, this is also this is also for strict programming languages like C++, C. But with Python, it won't be a problem for us. It also asks, can you solve this problem in O1 extra space complexity? The output array does not count as extra space for space complexity analysis. Okay, actually that's what I wanted to do, that I thought of doing, but yeah, let's see. The main restriction right now is ON time, right? So just to iterate, okay, let's state the brute force solution. Let's draw it, which is usually a good idea. So we have 1, 2, 3, and 4 in our array. And then we're going to start, for example, the first index will point out this to this place. And then we can have a second pointer that starts from the start, and we'll check, okay, if this index is the one that we have already chosen, yeah, okay, then let's move on to the next one. Is it the one that we've already chosen? No. Okay, let's multiply it. So at the start it was, for example, the product was 1, and then you multiplied it with 2. So it's 2 right now, right? and then you're going to move on to the next one, and yeah, you'll just multiply it by 3, and the next one, which is 4, um, sorry, yes, it will be 4, and you'll multiply it, and it's 24, and you're going to, after iterating over elements of all elements, you're going to write it to here. So in the next iteration, it can be something like 22, 3, and 4. Okay, and then the pointer will point out to this one. And we'll start again with, is this the one that we've already chosen? No. Okay, let's start with multi. Oh, do you see what is this problem? So when, if you do it in place, then you are modifying the array. So in the next iterations, it will create a problem, right? So you have to store this information as a separate list. So it should be, let's do it, let's clean it, everything. So basically you have a resulting list that will exist here. Probably you can do it like this at this time. So it's like a list of one element for now. And then you are going to move the index, sorry, move the index to the next one, and then start iterating from the very start as well. From here, check if it's already chosen. Okay, not chosen, then multiply. Then this one, oh, it's already chosen, skip this one. Okay, this one, multiply. Okay, this one, multiply. Okay, we are at the end of the list. Then we can multiply them, which is 12. Okay, let's append this to our list, resulting list. 12, right? So it will go on like this, and this iterator will go on to this one, and we'll do the same operations again and again. And the time complexity of this is on square, and that's the problematic part. If you're going through, basically imagine this is as two for loops, because one for loop iterates over this blue thing, iterates over all elements, and for each location of this for loop, for example here, we are going over 1, 2, 3, 4, all of the items again and again, right? So it is, therefore the time complexity is n times n, which is O n square. So this is the brute force solution, and the space complexity of this is O1 according to this thing. The output array does not count as extra space. Okay, so this was time, and space complexity of this solution is O1. And O1 space. Okay, so now we can think about a bottleneck. Not a bottleneck, but something that we repeat a lot, right? is there something that we are repeating here? So actually there is something, which is you are interestingly multiplying the same elements again and again and again, right? So if we were to have a look at this part, for example, in here you are multiplying 3 4 3 2 3 4, right? And then if you move here, then you're multiplying 1 3 4, and then when you move here you are multiplying 1 2 and 4. So it's actually like only this thing changes, but the rest of the thing is identical. So if we were to have some kind of pre-calculations on this array, can we do it? Like, so let me put it here, or maybe let's move on to the next. So let me write it back here. So one idea that comes to my mind is let's generate some arrays out of it. Okay, maybe we can use some of them. So one thing that reminds me is like you can multiply everything, or you can multiply, for example, at each location from here you can multiply it up to this point, right? 1 for this up to this point is 2, for here it's 6, and for here it's 24. Okay, so it means at the position I will have the all prefixes of it. Oh, actually, okay, this reminds me something. You can perhaps not do it like that, but maybe up to that point, so this is one version, right? Okay, let's keep it as one version. But the other version could be even more simpler. For each I will have the prefixes until that. So here it's 1 because the product of the prefixes, okay? So it's an empty array, an empty array product, I don't know, let's call it 1. For here, for 2, you can make it, you look at the prefix array, which is only 1, has only one element 1, and it's the product is 1. For 3, the prefix array is 1 2, so multiply, it's 2. And for 4, it's 6 because the array is 3 2 1, you multiply. So this is the prefix, maybe I can do prefix product. Okay, and now let's have the same for postfix product. For this item, let's look at the post array, which is 2 3 4, so make it 24. For this one it's 12, and for this one it is 4, and for the last one it is 1, right? So when you have prefix product and postfix product, what you can do at this point is just multiply them, whatever you have. So, and at the end you have you can multiply, and the result array will be 24, 12, 8, and 6. Is this the result that we want? Yeah, for this one it was 12, 24, yes. For this one it's 12, yes. This one is 8, yeah. This one is 6, yeah. I think it's done right now. Basically, you're calculating the prefix products and postfix products, um, and then you are going to so calculating this one is on time because you're going iterating over this one time, and calculating this is also on time. So time complexity is like on plus on, which is also on, right? And the space complexities, you have to have a separate arrays for each of them. This is on space complexity, and this one is as well. So as a result, we'll have on time space complexity as well. So on time, on space complexity, and the resulting array we are already returning at this point. Before moving on to follow up, I would actually like to implement this solution, but just to have it in mind, maybe it's the follow up is not so difficult. So basically, in the follow up, to come back here, we don't want to have any extra space complexity. And this reminds me of a trick. Usually, with your input array, which is this one, right? 1, 2, 3, 4. You can also make it, you can also change the elements of it. You can make each element as a tuple, for example. If it's not so big, like if it's one or two items, or like basically some number that is not scaling up, okay? You can write these prefix and postfix product into this elements as well. So within this, so let's move on to, let's do it in red, okay? So it will be something like, maybe I can start a bit more here. Let's store the value here at first. Um, You can make it like, you can, it's a tuple of, it's a very terrible one. It will be a tuple of 1, and at first you can make it, I don't know, let's fill the prefix first, okay? You have a look, okay, it's 1, prefix 1. By the way, I forget about the calculating the postfix product. It has to start from here and multiply with this one, multiply with this one, multiply with this one. So in the implementation, it will be clear, but something to. So otherwise, if I start over here and look at it and multiply it, it doesn't make sense because you'll be repeating yourself. This will be on time. Like calculating this one is also important, the way you calculate. But anyways, so I think that's a trick that I will mention. So whenever, like, you can have it at first as nulls, okay? At first iteration, you can make it like this, null, and it will go like this. And the next iteration, you can start with the prefix products, right? You can fill it. So for here, the prefix will be 1, and the item will be null, right? And it will go on like this. And in the end, in the postfix one, you will fill the other thing. So if you will start from the last one, which was the values 4, and the prefix of it is 6, and you'll start like looking at the right with the postfix array. So it's empty, so the product should be 1. So you will be filling up on this direction, and as a result, you'll have you at the end you'll have something 1, 1, 24, right? And then you can clean it up, make these tuples into an array integers that only shows the last value, which is the sorry, it will have a look, sorry, it will multiply this one, prefix product and postfix product, and it will write it down. So it will be 24. So for the second item, 1 plus 12, it will be 12. For this item, 2 times 4, 8, and 6 here. So this will use on time complexity again, but the space complexity is basically O1. But in case like you can also keep the input array same as this, so you can basically copy it into this, okay? So that perhaps you can remove this item as well, the first value, and it will be null, null, null at first, and you'll create it. So this will be ON time complexity and O1 space complexity. Let's move on to the implementation. So as I said, I'd like to for num, in nums, none, tuples, right? The thing is, I'm not able to modify an element in a tuple. So I would like to have it like a list. Sorry. So I can update it easily. And this will be the pre and post. Pre-post, let's say. So this will be the overall structure. We'll fill the pre-products, okay? And then we'll be filling the post products, and then we'll clean or like multiply pre and post, okay? And then basically return whatever you have, which is pre-post products. All right. So let's start with the filling. So you'll start from the very start. Let's go through like this. With a iterator, it will start from 0, and basically you'll have a look at I don't know, maybe can do it like this product, and you can start from directly from 1, and you can actually no, you have to update it. But yeah, if I is 0, you have to just write it there immediately for the pre-products. I, the first element we are updating, will be product, right? Else, you're just going to multiply, so this value will be multiplied by the one before, all right? The one before times whatever you have at this index. Actually, no. Not whatever you have here, but whatever you had in the previous index. And this situation protects this one, right? This being out of bounds. Perhaps you don't really need a product here in this case. You'll just start with this and it should work. And then we'll do the same. But we'll go in a reverse fashion. All right, we'll start from the last item. We'll iterate. We'll go until -1, and which will be the last element will be 0. The first element, okay, and it will decrease by 1. This I value in each loop, and we have to check right now if I equals to len nums -1. Basically the edge case. Let's start with it again. And pre-post products, yes, I. And now we are updating the second element there, which is the post product, right? You are going to set it up as 1 again, yeah. And else it will be identical. We'll update this value. And here in this case, you are going to multiply it with the one on the right, not on the left, right? So this is it. So this is updating it and multiply. And for each one, now we're going to change this thing. Whatever it is, it's identical, so that we can also use this length. So we're going to update this value here with the first element times the second element, right? And then that's it. Should be fine. If we have to go over from this in another input, let's see. So this is a length of 5. For each num, we are creating this array. This has a length 5. And for each of these numbers, if I is 0, which is case for it is, its left product is 1, right? For the next one, it will be 1 times -1. Which is -1. For this one, it will be -1 times 1, which is -1. For this one, it will be -1 times 0, which is 0. This will be also 0, right? And for here, it will be 1, right? Postfix. And yes, I think so. I think it's working right now. Let's see. Let's submit. I think I'm confident. So interestingly, it's this is yeah, I don't think it's slow. I don't know the reason, but it's the complexity wise, it should be okay. It's ON time complexity and O1 space complexity. This is the output one, and that we are modifying along the way and returning. It's the output one. All right, I think that's it for today.